Bismillahirrahmanirrahim. Welcome back, dear students. I am Mr. Kadim Khan and I am a lecturer in the Institute of Computing, Kuwait University of Science and Technology. We were discussing the non-functional requirements and its types. We have already discussed first two types of non-functional requirements, that is the product requirements and the organizational requirements. Now we are discussing the external requirements. External requirements are split down into multiple other types of external requirements. So external requirements are those requirements which are external to the organization and to the product. It includes, for example, interoperability requirements. Interoperability means that the system is interoperable with the other products as well, or the system is in fact transferring the data or making communication with the other products or with the other components. Second one is the ethical requirements. Ethicals are also called the moral requirements. That means that the system should not damage any others ethical situations, or it may be ethically very strong system. For example, it should be unbiased systems for different types of ethnics. For example, it should not attack anyone personally. That is the ethical requirements. The next types of requirements is called the legislative requirements. Legislative means those requirements which require certain law and regulation of the country. But legislative requirements is now split down into privacy requirement and the safety requirements. Privacy means that the data must take the private information of the customers very much safe. So that is the privacy requirements, that the system should not be used by everyone and it should keep all the data for a particular custom as he or she want to make it very much safe. Similarly, safety requirements also is like the privacy, but safety means that the system should keep all its operation very much safe from another. All the other softwares, for example viruses, etc., should not damage the system. That is called safety requirements. Now again, these are discussed in a very much detail here. For example, the availability, which is the non-functional requirements. Availability means that it is the measure of the planned uptime during which the system is actually available for use and fully operational. For example, if the system is failed due to certain reason, it is the uptime, that is recover times after failure. That is called the availability. More formally, availability equals to the mean times to failure, MTTF, mean times to failure for the system, divided by sum of the means times to failure and the means times to repair, MTTR. So this is the matrix of the availability. So here availability is equal to means times to failure divided by means time to failure divided by means times to repair. So means times to failure means the average times the system has failed for a particular period, and means times to repairs means the means times are the average times the system has been repaired for the particular period. So that's why this is the equation of the availability, that availability is equal to MTTF divided by MTTF plus MTTR. So scheduled maintenance period also affects availability. For example, if the maintenance period is very much long, then it will affect the availability. Some authors views availability as encompasses reliability, maintainability and integrity. So reliability, maintainability and integrity are the similar terms of the same as like the availability. Similarly, availabilities are more time critical than the others. So the user becomes very much frustrated when they need to get essential work done and the system is not available. So that is the availability problem. So which tasks are most critical system? For example, time-oriented system where we require that the system will work under certain times. Then the system is not responding, then this is the availability issue. For example, online quiz systems, when the questions in the quiz are in fact they have particular seconds. For example, after 10 seconds one question is changing. So but the many systems, or the internet is down, or the system is not very much good good in performance, then the availability problem will occur and the customer will get frustrated. So that's why such a system requires availability as a quality assurance activities. So that's why availability is very much important. And also you can think about many other systems for which availability is very much critical. For example, mission-oriented system availability is very much critical, and you can also think about other. This is your own task that you can identify many other softwares where availability is considered very much important. Another quality attribute is called efficiency. Efficiency is a measure of how well the system utilizes processor capacity, disk space, memory, or communication bandwidth. This is called efficiency. For example, processor capacity, if we have a good quality or larger processor with a good megahertz capabilities, then the system will be efficient. And also, if we have a good disk space, for example, we are using the SSD hard disk, then the system will be very much efficient. Also, our RAM is very much high and having a good quality and also high space in the RAM, then the system will be efficient. Also, communication bandwidth is very much large and having a good quality bandwidth, then the system will be very much efficient. Efficiency is related to the performance. Another class of non-functional requirements. Sometimes efficiency is also called performance. It is another types of non-functional requirements. For example, performance means number of transaction performed in a unit time is called performance. So it also depends all of these parameters. If a system consumes too much of the availability resources, user will be encountered degraded performance, a visible indication of inefficiency. So for example, if system is taking a lot of times to process the data, that means the system is not efficient, it is inefficient system. Another quality attribute is called the flexibility. Flexibility means easily the system can be changed. So flexibility measure how easy it is to be add a new capability to the product. So the system should be easily maintained, then it is called flexibility. If the developers anticipate making many change enhancements, they can choose design approaches that maximize the software's flexibility. So if the developers want to make changes in the system and want to enhance the system, so they can in fact improve the flexibility of the system. Basically, the system should be developed in such a format that we can easily improve the flexibility. This attribute is essential for the products that are developed in an incremental or iterative fashions through a series of successive releases or by the evolutionary prototypes. So basically, when we want to make the system very much flexible, so we should use the incremental or iterative approach for the development. Incremental approach, we already discussed that it increases the functionality and launch new increments in the products. And iterative means that there should be many loops for the developments, that many times the system should be developed. For example, if the first system which is not very much the enhanced system, it should be delivered to the market as like the beta version, and then we should take the feedback from the customer, and when the customers gives us the feedback, then the system should be maintained again and the next iteration should be launched. Next one is interoperability. Interoperability means that the system should be interoperable in other environment as well. The system should be in such a format that it can be easily installed in every environment, and it can work on all sort of the hardware and software environment. Then this is called interoperability. Interoperability indicates how easily the system can exchange data or services with the other system. For example, sometimes we require built-in components. We buy these components from the web, and then we download these components and we integrate these components with our current system. And these components are in fact developed into another technologies, and our system is usually developed in another technology. So we have to use interoperability services that can make the system interoperable. and that system should be used in every environment. The next one is called reliability. Reliability means that the system should work in every situation and system should be very much reliable. So it is the probability of the software executing without failure for a specific period of time is known as the reliability. If the software is not failing, that means software is working and every time the 24/7 approach, then the system is very much reliable. So we have to make sure that the software reliability include the percentage of the operations that are completed correctly and the average length of the time of the system run before failing. So that means that system should work correctly in a particular unit of time. And if the average length of the time of the system runs before failing, it is called the reliability. Another one is called robustness. Robustness means that system should have a strong capability that it should withstands against many types of the threats. So robustness sometimes also called fault tolerance. The system should have the ability to detect the fault and tolerate the fault. So it is the degree to which the system continues its function properly when confronted with invalid inputs. When the invalid is provided to the system, defects occurs during the operations of the system, that is connected with the software or hardware components, or unexpected operating conditions, then that is called the reliability system. So the system should do its function correctly in every situation. So robustness means that software recovers gracefully from the problem situation and it is forgiving of users' mistakes. If the user provides some mistakes or in the form of the invalid input, then the system must perform very well. When eliciting robustness requirements ask user about errors condition the system might encounter and how the system should react. So the system must give us a valid information when the user gives us some wrong input. So the system should help the user in this situation. Next one is called usability. Usability means that the system should be usable in every environment and should also be easily usable. So it refers to the ease of use by the human being. So if the system is very much difficult and it is not user friendly in terms of its graphical user interface, then we will say that the system is not usable. So human engineering usability addresses the merit factors that constitute what users often describe a user friendliness. So if the system is user friendly, then we say that it is highly usable. For example, take the example of the Windows. Windows are very much user friendly as compared to the another Windows like Linux, Unix. Linux, Unix are for the programmers, while the Microsoft Windows are for the common users. So common user using multi sorts of the icons or the buttons etc. While the Linux and Unix are in fact that mostly we use through the terminals by using different commands. So if we type the wrong commands, it will not be workable, while the Windows can be easily used. So that's why we can say that Microsoft Windows have high usability as compared to the Linux and Unix. So usability measures the efforts required to prepare input for operate and interpret the output for the product. So that is called the usability. Next one is the integrity. Integrity means that system is very much strong. So the web surfers don't want personal information or a record of the sites they visit to be used inappropriately. So integrity means that the data is very much safe and the web surfing is very much safe and the usage profile of the user is also very much safe. Integrity can also be called security, privacy. So also there is the no tolerance for the errors. Then we'll say that the system is not so much integrable. So integrity is called security. Security means that the system should make all the data very much secure. there should be strong encryption decryption algorithm. Privacy means that all the operational usage and the data and other information of the system should be private and they should not be shared with anyone. So integrity requirements have no tolerance for the error. Another one is called the maintainability. Maintainability means that the system should be repaired very much easily. So maintainability means that the system should be maintainable. That indicates how easy it should be corrected after a defect or modified the system. So when the defects occurs, the system should be corrected very much easily. Maintainability depends on how easily the software can be understood, changed and tested. So that is called the maintainability. It depends on how easily the software can be understood by the different developers who want to maintain the software, and also can be easily changed. The coding and the databases and other component of system can be easily changed, and also it can be easily tested. Then we will say that system is very much highly usable. Dear student, this is the end of the lecture. If you have any question, you can drop an email to my ID. My ID is m.kadim@kust.edu.pk. I will wait for your question. This is the references. You can study this book for this lecture. Thank you very much.